Thank you for joining us on today's webinar. You are in a listen-only mode. If you have a question, please type it into the Q&A pod on the left-hand side. I would now like to turn it over to Jack Park.
Hello, everybody. My name is Jack Parks. I'm a consulting systems engineer for Juniper Networks. Today, we're going to go over the steps for migrating your network from EIGRP to OSPF. A little bit about myself. I've been with Juniper Networks for about 7 years, and before that I worked at a Tier 2 service provider, and actually have performed a couple migrations from EIGRP to OSPF. So we'll go ahead and get started. If you have any questions, there's a Q&A box that you can type your questions in, and we'll address them as soon as possible. There are several sections that we'll be going through, so if there's a particular section that you have a question or comment about, I'll be glad to pause and address your question or concern at the conclusion of each chapter. But so let's get started. All right. So the agenda for this presentation is we're going to basically go over EIGRP versus OSPF. We're going to talk about some of the network discovery techniques that are, in my opinion, required for a migration. We're also going to talk about mapping the network. Again, this is kind of taking all of that discovery information and documenting it in an offline fashion. We'll go through the steps required to migrate the network and its verification. And finally, a little blurb about OSPF versus ISIS. Okay, so EIGRP versus OSPF. I don't want to spend too much time on this. IGPs can kind of get into one of those debates where folks have their preferences, but essentially the main reason why you would want to go to OSPF is because of its open nature. It's supported by almost all vendors out there, including other network appliance vendors, for WAS type appliances or application acceleration, those types of things. So having an open protocol on your network is also allows you to connect to these types of devices for redirects and things like that. The other thing is EIGRP is, for the most part, developed and maintained by one company. We'll talk about the latest informational RFC that Cisco released about EIGRP, what benefits that brings and what is not included in the open EIGRP standard. We also have, there's also a lot of large networks, ISPs and such like that, large enterprises. Most of them is standardized on open protocols as well. So OSPF or ISIS, the big reason is scaling, right? You can build a hierarchical topology with a SPF-based protocol. And there's also some other nice things like multi-topology support, so you can have multiple paths to your networks with different SPF calculations happening for specific types of traffic. I've listed the RFCs for the multi-topology support. Juniper supports multi-topology in both OSPF and ISIS. All right, so let's touch on the EIGRP RFC. I linked, the presentation will be available afterwards, but I've linked Cisco's FAQ about the EIGRP informational RFC at the bottom of this slide. But essentially, Cisco is going to maintain control or the direction of the protocol. So there's some features that they've left out, the stub areas, a lot of EMVPN scaling, and things like that. And so essentially what you get is just the core EIGRP function with the EIGRP RFC. Reading a lot on this, commentary from bloggers and things like that, one of the big can't think, downsides, that they're saying about this is essentially this open EIGRP is a little too late to the game. Most people have kind of decided on which IGP they're going to use, and if they're going to convert their network, it's not going to be to EIGRP at this point. The reason is, as we virtualize networks, as the SDN discussion, comes more into play, and we talk about open flow and programmability and things like that, IGPs are beginning to be, their importance is being diminished. They're really just for next hop reachability and things like that. So moving to a proprietary protocol or a limited open protocol doesn't make a lot of sense. Some other things about OSPF and a lot of and ISIS for that matter is, a lot of folks like the feasible successor, the fast failover of EIGRP, and for years it had kind of the corner market on failover times, but since RC 5286, we now have something called loop-free alternates. You can also see that some folks still call it IP fast reroute, and essentially it brings that fast convergence to the SPF calculation. And the way it works is Dijkstra is run to get the best paths for the network, and then after the network is converged, there's a second Dijkstra run that computes the next best path. So that information is then stored in the forwarding table, and in the event of a failover, we don't have to rerun Dijkstra. We simply switch over to the new, or the backup path, if you will, the feasible successor, and we can achieve really fast convergence. The goal is under 50 milliseconds. That's kind of the industry standard fast reroute failover time, and so the convergence is pretty fast. So if you have a lot of equal cost multipath links in your network, loop-free alternates doesn't really buy you anything, but if you have a lot of unequal costs, then loop-free alternates is a great addition to OSPF or ISIS to speed convergence. And finally, one of the reasons why we would choose OSPF over EIGRP really comes down to this big push towards network virtualization. Network virtualization is basically, today, is MPLS, right? It's constraint-based routing, it's building a traffic engineering database, it's selecting paths based on information other than link cost. So a lot of things like link coloring, so take the blue path instead of the red path. Bandwidth constraints. If this particular link is 90% saturated, then we're going to use another link. A lot of these types of controls are only available within an SPF-based protocol. And then finally, with network virtualization, the possibility of connecting to virtual machines and things like that, we need a standard way to interconnect. So a proprietary protocol like EIGRP presents some problems depending on your virtualization, server virtualization technology. And again, with network virtualization, another big topic that keeps coming up is this software-defined networking. And the IGP is really becoming marginalized in the network. It's still important, but as we see these types of new features and functionality come out, it's not as important as it used to be. All right. So let's go over some network discovery techniques. And this is probably one of the more important aspects of converting your network from one interior gateway protocol, IGP, to another. So let's touch on some strategies. We'll go into it a little more detail in each slide, but when you're converting your IGP, we get to play a little game with administrative distance. Administrative distance is the value that a router places on information that it's learned through protocols. We'll also go over 3 different models to facilitate a conversion from one protocol to another, one IGP to another. And I want to talk a little bit about EIGRP normalization. So let's dig into understanding administrative distance. So administrative distance is essentially a numeric value that gets placed on learned information. For example, a connected interface has an administrative distance of 0. The lower the distance, the more preferred it is. So a connected interface, if I learn a route or if I know about a route that's connected to me, I'm always going to prefer that over anything else that I might have learned dynamically. So I've made a chart of administrative distance, and Juniper uses a different term, but it's essentially the same thing. We call it a route preference. So when you hear administrative distance and you're doing something on a Juniper device in Junos, we're going to talk about it as a route preference. There are some differences between Cisco's implementation of administrative distance and Juniper's implementation of route preference, but the effect on your network is the same. For example, obviously Juniper has no EIGRP equivalent, but let's look at OSPF. So OSPF for Cisco has an administrative distance of 110, meaning it's less preferred than EIGRP, which has an administrative distance of 90. In Junos, OSPF has an administrative distance of 10. ISIS is 9, I believe. But something else to point out, OSPF is the same whether you're learning it external through the OSPF process or you've redistributed a particular prefix in the OSPF. So Cisco shows 110 administrative distance for both. In Juniper, we've actually separated those out. So all natively learned OSPF routes have an administrative distance of 10. Anything that you've redistributed into OSPF and Juniper will have an administrative distance of 150. Now, I point this out for a big reason, because when we start the migration, if you have a lot of EIGRP externals, when we convert everything over to OSPF, you'll notice that OSPF has a better preference in Juniper. So if you have any Juniper devices in your network, there's a possibility that you can propagate the wrong information, or the wrong information won't be propagated to EIGRP only speakers. So when we get into that section of the presentation, I'll point out the differences and how we get around that. But understanding administrative distance is the key to a successful migration, because this is how we're gaming the system, if you will. This is how we're making the conversion happen without a lot of impact to your network. Conversion models, we essentially have 3 primary models. We have an overlay model, which essentially is I'm going to run EIGRP and OSPF in parallel, which allows me to essentially migrate the network live, and it really doesn't have a lot of impact to the network itself. We also have a redistribution model. So what you end up doing is finding a natural redistribution point, and you can migrate your network in a large chunk. So if I have a specific area, a natural conglomeration of routers in a particular area, I can migrate those and then come back and do the rest of the network at some other time. And then the last model we'll discuss is the integrated model, which essentially is I'll build a new network, and as I cut pieces of the network over, I'll convert them at that time. So to give you a visual of the different conversion models, I've created a drawing here, and essentially there's multiple layers to a network, right? Core, distribution, access. The overlay model essentially is I'm going to overlay OSPF on top of the network while EIGRP is running. And then I'm going to remove EIGRP in a regimented fashion, so all that I'm left with is OSPF. Let me pause for just a second. Up front, I forgot to mention that a lot of this information is in the Day One guide called Migrating EIGRP to OSPF. All the diagrams and the examples that are in this presentation actually came from the text of the book. So if you want to get a little bit more in-depth detail about the different conversion methods or administrative distance or things that we've discussed or will discuss, it's all contained inside of the Day One book. All right, so the conversion model, I want to kind of preference this, the overlay conversion model with, there's a lot of upfront work when you're going to do the overlay model. But in the end, it's going to accomplish several things for you. So the big thing it's going to do is help you clean up the network. Networks evolve over time, and there's a lot of things that go unused, or it's done a new way, a better way. So when you're going through the conversion, the overlay model, you have to go through and kind of fix the way your protocols are designed, maybe add passive interfaces to loopbacks, a lot of different things like that. So it fixes a lot of configs, but the upside is there's a lot of OpEx work, right? So there's a lot of labor, but there's no spend. You don't have to buy any new gear. Another nice thing about the overlay model is it's hitless. Again, I'll preface that unless something gets messed up in the conversion, but we're going to go through those steps to ensure a very smooth transition. So the only thing you really have to watch out for, if you have some legacy equipment that cannot take two protocols running at once, whether that's because of CPU limitations or memory limitations, or it could be small office, home office type connections that are low bandwidth links where you really don't want two protocols sending route updates across a low speed WAN link. Okay. The second conversion model is the redistribution model. Typically, there are natural redistribution points in your network. So just finding those and developing the policies that you need can make this one very much worthwhile. So what it allows you to do is kind of convert sections of the network and then redistribute the OSPF to EIGRP routes. In effect, so you can maintain that connectivity. So some key points to think about on the redistribution model is it really allows you to focus on areas that need converting, right? Whether that's a new data center or a revamped data center. If you have a really, really large network, it's just too much to do the overlay. This model is very effective for kind of dividing up the work. The things you really have to watch out for is if you have more than 2 redistribution points, because what you're going to have to do is create some complex policy to prevent, learning an EIGRP route through OSPF and then giving the EIGRP route back to OSPF. Learning the EIGRP route into OSPF and then OSPF giving that same route back to EIGRP. You get a lot of those types of issues. So if you've ever attempted the CCIE exam, multiple redistribution policies is one of the key gotchas that they like to throw into the exam. So if you're not comfortable with complicated redistribution policy, this model might not be the best for you. Then finally, we'll talk about the integrated conversion model. And essentially what you're going to do is create a second network, and you're going to migrate pieces of that network over to the new network. So when is this a good idea, right? When is this type of model is a good idea? So essentially, the network is very outdated. It's not worth fixing. I mean, the time it's going to take, there's more issues than just your IGP, right? Maybe it's lack of interfaces, or you're doing a big network migration anyway. You can simply install the new network, and as you move pieces of the network to the new network, then you make the conversion. So a couple, what's problematic about this approach is essentially it's going to require a capital expenditure for the new equipment. So if this transition model is really best if you're going to make to do this anyway, right? If you're going to upgrade the network. So it's extremely disruptive. There's no way to do a hit list while you move components, whole sections of the network over. And then you have to watch out, again, for redistribution challenges because you'll end up with parts of your network that are new, that are running OSPF, and you'll have parts of your network that are legacy that haven't been converted yet that will be running a different IGP. Okay. The last thing I'm going to touch on in this section comes down to what I call EIGRP normalization. So what does that mean? So essentially, if we look at the top right, I think I can draw. So if we look at the top right section of the slide here, you'll see that I've got a typical EIGRP protocol, typical EIGRP protocol SNP, right? And the problem with this is I'm redistributing connected interfaces and I'm redistributing static routes. So if you want to get static routes into your network, you need, this is the only way to do it. But know that these become external routes, right? So they're EIGRP externals. Also, if you look at redistribute connected, what I'm doing is I'm taking all of the physical interfaces in that device and I'm making those EIGRP externals as well. So that's, in my opinion, that is not a very good way to deploy your IGP, whether it be EIGRP, OSPF, ISIS, doesn't matter. There's ways to get interfaces into your protocol natively, and I highly suggest that takes place. So in the lower left of the slide deck, of the slide, you'll see a normalized EIGRP config. So there's a couple things that I've done. First, I don't do a wholesale redistribution of static routes. I've actually created a route map that identifies the specific static routes that I want redistributed into EIGRP. And so I've added that route map to through the redistribution statement. The other thing I've done is I've expanded the network statement to include all interfaces on a particular router. If you look, I've got a basically 192.168/16. And then for those customer or user networks that I want in EIGRP, but I don't want to be sending hellos out of, I simply make those passive, like the loopback interface, and you can see with my fast Ethernet. So this is a better way to create your EIGRP policies. And this will help, you know, once you create it this way, this will help you with the OSPF policy as well. You'll see this policy in the lower right later on. We'll actually reuse it in OSPF. Okay, so let's get into mapping out the network. Okay, so mapping out the network, I want to really preface this. There is no shortcut to documenting what's going on in your network. The reason is there is no substitution for this type of documentation. When you get into the verification stage and, you know, finalizing the actual cutover, how are you going to know if all your routes made it? How are you going to know if your EIGRP process and your OSPF process match? Right? Once you delete the EIGRP process, you've lost that visibility. So we have to capture that information up front. So document, 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 right? You need a good network drawing. It's a great time to update your network drawings. Use a spreadsheet to capture all of your adjacencies. Use a spreadsheet to capture your route table. Most enterprise route tables are only about 100 to 200 routes. Now, if you have a larger network, I know there are some folks out there with 3,000 to 4,000 routes in their IGP. The spreadsheet gets a little cumbersome. However, there are other methods to documenting this information. If anybody's good at scripting, the big thing is if you don't have the information, you can't reference it later. All right. So let's talk about the network drawing. You can see my super huge network here. This is the topology that we actually used in the book that walks you through the process. But essentially, there is no substitute for a network drawing. It gives you the ability to visualize everything that should be connected and should be adjacent in your network. The other thing, too, is your network drawing has to agree with what's on the devices, right? There's no reason, if you're missing an adjacency or a connection on your drawing, but it exists in a router, there is a possibility that you won't be able to, or you'll miss that verification step. So you really have to be careful with that. The other thing a good network drawing does is it allows you to figure out which migration model will work best, right? So overlay, if you have a small network, I'd say a small network would be under 50 routers. If you have a larger network, you might need to look at the redistribution model. But it's going to show you natural aggregation points. It's going to show you a lot of good information that you just can't get from text. So network drawing is crucial. Other things that need to happen is, while you're going through and normalizing your EIGRP config, you might want to take a quick snapshot of your interfaces. What interfaces are up, what's the IP address? What's the what are the adjacencies? Did we redistribute connected, or are we doing it properly with passive interfaces? And in the end, to be successful, we're going to have to get OSPF adjacencies to equal your EIGRP adjacencies. So a quick view of the CLI. Essentially, I have 3 commands that are shown on the slide deck. It's basically look at the interfaces, look at the EIGRP interfaces, right? So these will show your passive interfaces as well. Now, if you do redistribute connected, you're not going to see them in under show IP EIGRP interface. They have to be in the process itself, so native to EIGRP, and then they'll show up and they'll be passive. And of course, you want to look at your neighbors. So this is the type of information that we need to be capturing on a per router basis so that we can use it to verify the network later. The route table, so the statement that sums this up the best is if you have more EIGRP routes than you have OSPF routes, when this conversion is completed, you're essentially going to have a network black hole. Whatever prefixes are missing, will be black holed in the network. So getting your interfaces and adjacencies down is great, but the end goal is to have a consistent route table from what you had with EIGRP to the exact same route table you have with OSPF when the conversion is complete. The 2 commands, one didn't bold out really good, and I apologize for that, but a good way to snapshot and see how many routes are in your network is show IP route summary, and that basically shows, EIGRP has 2 routes. I have 5 connected interfaces. There's no static routes on this particular box, but it basically goes through and shows you in a quick snapshot what's on the device itself. And then to look at the actual routes themselves, you would do just a show IP route, and you can kind of see all of the prefixes that are installed. Okay, so I made a quick offline document. In this example, I used a spreadsheet, right? So here I have all the interfaces in a spreadsheet for each router, and what interfaces in that router those IP addresses belong to. So I'm not going to read, if I can get my mouse to work. Okay, so I made a super verbose summary, but I'm not going to read this to you. Essentially, what this says is, without a proper snapshot of your network, there's no way to tell that you are successful until you get the help desk calls, right? A lot of this work can be done in a hitless fashion, but if you don't know where you started from, how do you know you got to the end? So make your network drawings, get your interfaces documented, get the adjacencies documented. Without that information, or get your route table snapshot. Without that information, we can't be sure that we're done. All right. So the migration steps. So this is my little checklist, right? If all of these steps have been completed, if you have this information, we can start with the migration. And to do that, we're going to essentially turn on OSPF in 3 phases. So the network's ready to go. We've got all the prep work done. So now, how do we begin the migration process? And essentially, it comes down to we need to turn on OSPF, and we're going to have to change the external administrative distance for OSPF. Remember that in Cisco, the administrative distance for OSPF externals is the same as OSPF internals, but EIGRP uses two different administrative distance for internal and external. You'll see where the problem lies here in a second. We'll add interfaces, and then we'll finally use our redistribution policy to kind of get those external routes into OSPF. So phase one. It's actually pretty simple. Now, there are some best practices that I like to implement. Every router should have a loopback in your network. If they don't, this would be a part of the normalization process before you begin. But every router should have a loopback. And the best way to do that is take a /24 from your RFC 1918 addresses, and then basically assign every router a /32 from that /24. That gives you 254 routers that will be supported through that. And it also helps you build firewall policies, what's allowed to telnet, what's allowed to SSH to your devices. So good best practice. So we're going to set a router ID to the loopback. The reason I like to do this explicitly is if you have the loopback before you begin, then it kind of takes it automatically. But I'm not a type of guy that likes to leave things up to chance. If we can explicitly configure something, I would rather explicitly configure it, get it right, than rely on chance or a process doing what it's supposed to do. So simply put, we're going to do router OSPF 1, that's the process number. I'm going to set the administrative distance for external routes to 175, which is above EIGRP's external administrative distance. And that's all we really want to do. All we're doing is prepping OSPF in phase one. So we're going to go through and just make sure the process comes up and there's no problems. The next thing we're going to do is we're going to start in the core of our network. I can't express this enough. So from the core of the network, we're going to start adding interfaces into OSPF. Now, my little config snippet here doesn't show that we set the router ID and things like that because that's already done. So this is inclusive of what has been done before. So again, don't redistribute connected, don't redistribute statics yet. Simply add the interfaces with a network statement so it encompasses the entire router, and then do passive interface for every interface that you don't want to send hellos out. We want to keep internal interfaces in your protocols natively. We don't want them to show up as externals. And again, you have your documentation of what EIGRP was configured. We need to match them up to the same. It's the exact same syntax. It's just under a different IGP router process. And finally, phase 3, we're going to borrow our route map that we used for our redistribution policy and use that exact same route map under OSPF. So the third thing we're going to do with OSPF is do our redistribute static subnets. Don't forget subnets. And then we're going to use the route map that was created for EIGRP. So essentially, I got you a little flow chart. So we created this policy with EIGRP. We're going to give it to OSPF and use it in our redistribute command. Again, don't forget the subnets or the subnets keyword, or you might not get your routes in there. Okay, so if you started in the core of your network and you worked your way to the edge, slowly adding these 3 steps, you should be done with your OSPF overlay. Now, if we've done it correctly and we've cleaned up EIGRP and we're not redistributing connected, you should not have any routes for OSPF in your routing table. Nothing should be different. So the only thing that's different is I have a process running simultaneously with EIGRP, and those routes, because of administrative distance, are not in the route table. If they're in the route table, we're going to have some problems. All right, so so we're going to verify OSPF first, make sure all the adjacencies are up, and you can see the 2 commands here: show IP EIGRP neighbor and show IP OSPF neighbor. So they're identical. We have the same adjacencies. Both of the adjacencies are up and fully adjacent. So, we're going to go through router by router and make sure all these things are good. Now, we can't see OSPF routes, right? We can't see the OSPF routes in the route table, but we need to make sure that those routes are there and available. So how do we do that, right? How do we see what OSPF knows, and is it equal to what the route table has at the moment? And the only way that you can do that is look at the OSPF database. So the OSPF database, consists of different LSA types. So you're not going to be able to see, just by saying show IP OSPF database, you'll just basically see the LSA types. You won't be able to see what routes are contained within each LSA. So what you're going to have to do is specify the different LSA types. In this case, it's a router, which is an LSA type 1. So essentially, you'll look at 1s, 2s, and 3s. So routers, networks, and summaries. And you should have all of the same routes. If you look, I have about middle of the page. This particular router, 192.168.1.1, has 3 links. They're subnetworks. These are networks attached to the device itself. You can see the network masks, so that's the loopback, the first one, and the second one is a connection between 2 devices. Which OSPF calls a transit network. So all of this is covered in detail in the Day One book, Migrating EIGRP to OSPF. Okay. Another little nugget I'm stealing from the CCIE lab is ping scripts. So a ping script is essentially, basically, it could be as simple as a text document that you can copy and paste that allows you, for every router, I can say, I want you to ping this loopback, this loopback, this loopback, this network. So you just, type ping, 192.168.1.1, ping 192.168.2.2, so on and so forth. And this ping script will allow you to verify that, yes, everything's up and running. You can build a traceroute script, which basically is traceroute 192.168.1.1, and to make sure that your paths are the best path in your network. Now, we can run that now. I mean, we're still running 2 protocols at this point in our migration, but we can use it again when we turn EIGRP off to make sure it's just another verification step to say, yes, the migration is successful. All right, so let's get to essentially the last step of our migration, and that's getting us back to a single IGP, right? all the hard work is done at this point. There's, don't leave EIGRP running on your network. So when you remove EIGRP, we're going to do it in the reverse order that we did OSPF. So OSPF was core to edge, core to access. When we pull off EIGRP, we're going to start at the access layer, and we're going to work our way back. If you think about this methodically, we unified OSPF from the core all the way to the edge. There's still going to be EIGRP speakers on the edge as we slowly migrate each device. So we're going to need to maintain EIGRP for some time as we work through the migration. So the core still has to be running EIGRP in the end. So that's why it's the last thing we change. So as you do this migration, as you type no router EIGRP, you'll start to see the OSPF routes show up in your route table. These will be propagated end to end, so there's no black holes. The other thing that's really neat is routers have a behavior that we call PHB, per hop behavior. And basically, even though they share a common topology, a common knowledge, they still make decisions on a hop-by-hop basis, on an individual basis. So if he has, so while I have OSPF routers that are autonomous from, or that are OSPF only, and I have routers that are EIGRP only, when it gets to the core, right, the core router will say, oh, I know how to get there. It's through EIGRP. So thanks to administrative distance and per hop behavior, this works out really, really well. Just remember, putting on putting on OSPF is core to edge. Removing EIGRP is edge to core. Here you can see I removed EIGRP, so the route table is kind of changed. I no longer have D routes, right, which are EIGRP routes. I now have my O's, my OSPF. And you can see that I have an OSPF external, which is that static route that was redistributed into the OSPF process. All my connected interfaces are native to OSPF. You can't see them here, but on other routers of your network, I should see 192, 168.30, 24, 40, all of those will be OSPF routes in the network. All right, so we had our ping scripts that we basically did to verify that everything's working. After we remove EIGRP, we can run our ping scripts again. So what I would do is every time you remove EIGRP from a router, run the ping scripts, right? If you run into a problem with that particular router, you can address it immediately. If you go through and remove EIGRP through your whole network, and then you run the ping scripts, it's too late, right? You've already kind of made the transition. So if you pause every time you remove EIGRP, run some connectivity tests, verify, and then you can fix problems as you go. The impact will be only to that particular device, and so it'll be just to that particular device. The rest of your network will be working fine. So the goal of this is to be as hitless and transparent as possible. Okay, so the final verification step is we're going to take all of the information that we collected in the beginning, right? The network diagram, our interfaces, adjacencies, the route tables. So EIGRP isn't there anymore. We can't go back and get the information. So how do we know we got the right, the network migration is complete, right? We have to rely on our offline documentation. And as we all know, being network engineers, nobody thanks you for keeping the network up, right? but they know exactly who to call when it goes down. So just document the network, keep that information, verify every step of the way, right? And you can get this done without any impact to the network, without anybody who needs to, who doesn't need to know that you're changing your IGP. You can get it done and, kind of move on with other projects on the network. So, again, I can't stress enough, verify, verify, verify. Okay. Coming to the end here. So the last thing we're going to talk about is OSPF versus ISIS. So when I initially wrote the Day One guide for migrating EIGRP to OSPF, I was talking to my tech editor. We were having a discussion, and we actually almost did EIGRP to ISIS. Now, why would we do that, right? I think the biggest reason that people are looking at ISIS at this point, especially if you have to migrate off of EIGRP or want to migrate it off EIGRP, IPv6. So ISIS is not an IP protocol. It's a ISO CLNS protocol. So it's completely extensible, and it supports IPv4 and IPv6 simultaneously. It also has some really neat functions. It can support MAC learning, and that's based under shortest path bridging, SPB. That's how SPB works, if you're ever going to look into that. So, it's a big toss-up for me. I mean, if you're comfortable with OSPF, I would definitely migrate to OSPF. If you don't care, or you're just looking for something a little better, or not better, different, not even different, but if you're contemplating V6, you're contemplating ISIS, I would make the same transition. So the steps work the same. EIGRP has a better administrative distance than ISIS. So you can essentially do the exact same thing that we did with OSPF in this presentation. It works the exact same. Yeah, quick rundown. Now, I do want to, again, reiterate something about IGPs. In today's networks, an IGP really is losing its old core functionality, right, which is reachability for everything in your network. Most people are using IGPs at this point to support higher up protocols like BGP, MPLS, those types of things. So when you start removing a lot of information out of your IGP, they use it for links and loopbacks is kind of the terminology. It really minimizes its scope in your network, and a lot of that functionality is transferred to something, a higher level protocol, again, like BGP or MPLS or things like that. And just make sure you don't overcomplicate your IGP. Most people don't need more than a single area, just one big backbone area. You can get 50 to 60 routers by Cisco's documentation. Juniper, we can support, I want to say, on our larger routers about 500, on our smaller ones, I believe it's about 300. So don't overcomplicate it. Single area is fine. Most of the newer devices have plenty of CPU to run Dijkstra. It's not the problem it was back 13 years ago. Just be smart with it. Don't overcomplicate it. Just lay it out there, and make the migration. So we're at 5 minutes, I guess, before our hour's up. I guess if anybody has any questions, there's a Q&A box. You can type in any questions that you might have, and I'll go ahead and answer those. But I really appreciate everybody tuning in to the webcast. So it doesn't look like there's many questions. Okay, I've got a quick question. So one question we got is, when is SDN going to completely replace an IGP? And that is actually a very good question. So I've been following SDN quite a bit. The big thing is, other than OpenFlow, there's not a lot of SDN implementations, right? It's still in flux. There's a lot of talk. There's a lot of ideas. And the big thing I'd say about SDN is, at this point, it's only used in specific areas, right? So if you have an OpenFlow-based router, we'll take that for example. Typically, it's used in a data center scenario. I think Google uses their OpenFlow for WAN circuits, but it's usually targeted to a specific part of the network. So there's always going to be IGP needed in different areas of your network. So will SDN completely replace an IGP? It's possible. It's definitely, in my opinion, 10, 15 years out. I just don't see programmable networks encompassing every aspect of folks' topologies. However, I think certain places in the network, like data centers, have a high potential for SDN protocols like OpenFlow. All right, I have another quick question. Let's see. Cisco has stated that they will standardize EIGRP in the future. Would we welcome or support this effort? Yeah, so I posted Cisco's frequently asked questions on one of the slides. So yes, it's an informational RFC that basically says that they're standardizing EIGRP and making it open and available to the anybody who wants to develop to it. But there's some caveats, right? I would you might be able to Google for the FAQ if you don't have it if you don't have the slide deck. But essentially, there's a lot of pieces missing from the standardized EIGRP, and Cisco is really controlling a lot of the advanced features. So it's kind of neutered in a way, right? It's not a full EIGRP. As far as Juniper support, I don't think we'll ever support EIGRP. The reason is we have plenty of effective protocols with loop-free alternates, with ISIS, with IGPs. ISIS. I mean, we've got fast failover. We've got a lot of the components that used to make EIGRP a fantastic protocol. And again, minimizing the IGP in the network in favor of network virtualization, multi-protocol BGP, all of those things. I just don't see the need for EIGRP at this point. It's just, again, I'll quote Network World, and it basically said it's a little too late to the game. Okay, so I guess I got 1 minute. Well, I barely have a minute, so I'm going to be real quick with this last question, and this will be the last one. From your experience, does LFA pick up backup router faster than feasible successor? So I've never done a head-to-head, but again, Cisco has a nice presentation on comparing OSPF, ISIS, and EIGRP. And in their test, EIGRP alone is slightly faster than an SPF protocol running LFA. And when I say that, I mean like a millisecond faster. So, I mean, if you want to split hairs, I would say yes, EIGRP is faster. But if you converge in 5 milliseconds versus 6, is there that much of a difference, right? As long as, I mean, if the industry target is 50 milliseconds or less, I think that's enough. Anyway, so I want to thank everybody for joining. Thank you for your questions. I really appreciated giving this presentation. And at this point, I'll turn it back over to Julie.
Thanks, everyone, for attending. I've listed the Day One book and where the webcast recording will be in the Q&A chat box. Thanks again. Bye-bye.